Welcome to this exploration of the paper that launched one of the world's most influential companies. In 1998, Sergey Brin and Larry Page, graduate students at Stanford University, published The Anatomy of a Large-Scale Hypertextual Web Search Engine. This paper described their search engine, Google, and introduced PageRank, the algorithm that would revolutionize how we find information online. Let's understand how a research paper became the foundation for a trillion-dollar company. To appreciate Google's innovation, we need to understand what search looked like before it. By 1997, the web had tens of millions of pages, and finding information was increasingly difficult. The major search engines, AltaVista, Excite, Lycos, InfoSeek, used keyword matching, ranking results by factors like keyword frequency and location. This approach had a fatal flaw. Website owners quickly learned to game keyword-based search. Keyword stuffing, meta tag abuse, and hidden text polluted search results, making it difficult to find relevant information. Search quality was degrading. The more the web grew, the worse search got. Larry Page and Sergey Brin met at Stanford in 1995, converging on a shared interest: organizing the web's information. Page became fascinated with the web's link structure, believing important pages would be linked to by many others, similar to academic citations. Brin brought computational and mathematical expertise, and together they set out to build a better search engine. Page had a brilliant insight. Links are like votes. When a web page links to another, it's implicitly saying this page is worth visiting. If many pages link to a particular page, that page is probably valuable, and if important pages link to it, that's an even stronger signal. This was a departure from looking only at page content. Now the web's structure became a source of information about quality. The paper introduces PageRank, named after Larry Page, not web pages. The basic idea: a page's importance depends on the importance of the pages linking to it. The formula: PRG plus DX, where PR is the page rank of page A, PR is the page rank of pages linking to A, C is the number of outlinks from page TI, and D is a damping factor typically set to 0.85. A link from a page with high page rank counts more than a link from an obscure page. There's an intuitive way to understand PageRank: the random surfer. Imagine a web user who starts on a random page, then with 85% probability, clicks a random link on the current page. With 15% probability, they get bored and jump to a completely random page, repeating this process forever. PageRank is the probability that this random surfer lands on any given page. Popular, well-linked pages get visited more often, while obscure pages get visited rarely. This probability distribution is PageRank. How do you actually calculate PageRank for billions of pages? The paper describes the power iteration method. First, start with all pages having equal rank, then apply the PageRank formula to compute new ranks, and repeat until ranks converge. The web graph is sparse, so this computation is practical even at scale. The paper reports that PageRank for 26 million pages converged in about 52 iterations. PageRank wasn't Google's only innovation. Anchor text analysis was another key component. The text in a hyperlink often describes the target page better than the page describes itself. Google indexed anchor text and associated it with the linked pages, providing additional information about page content. The paper describes a sophisticated system architecture, including a URL server, crawlers, repository, indexer, links database, PageRank module, and searcher. This system was designed to crawl and index the web efficiently, manage vast datasets, and retrieve and rank results based on relevance and links. The paper reveals impressive scale for 1998, 24 million pages indexed, 259 million anchor text entries, and over 322 million hyperlinks stored. All this ran on commodity hardware, standard PCs, not expensive servers, demonstrating that massive scale could be achieved through clever software on cheap hardware. Google combined multiple signals for ranking: PageRank for authority, content relevance, anchor text, proximity of query terms, and font size and position. The paper notes that no single factor could dominate. They balanced signals to prevent gaming. How well did Google work? The paper is cautious, but qualitative results were clear. Google returned more relevant results than existing search engines. The authors note, Our own experience with Google has shown it to produce better results than the major commercial search engines for most searches. Word spread. Within a year, Google was handling millions of queries daily. The paper includes a remarkably prescient section about advertising. We expect that advertising-funded search engines will be inherently biased towards the advertisers and away from the needs of consumers. Ironically, advertising became Google's entire business model, though they developed systems to mitigate the conflict. The timeline from paper to giant: August 1998, Google Incorporated; 1999, moved to real offices; 2000 became world's largest search engine; 2004 IPO raised $1.67 billion. Today, Alphabet is worth over $1.5 trillion, all from a paper about link analysis and web crawling. PageRank succeeded because it aligned with the web's nature, a decentralized quality signal where the web's millions of authors collectively vote through links. It offered recursive authority, spam resistance, and scale independence, working whether you have 100 pages or 100 billion. Google's quality forced competitors to improve or die. Alta Vista declined, Excite went bankrupt, and others faded. By the 2000s, Google had become a verb, processing most of the world's search queries. PageRank also created search engine optimization. Website owners now needed quality backlinks, not just keywords. An entire industry emerged to help websites rank higher, focusing on link building, content marketing, and technical SEO. Google continually updated its algorithms to combat manipulation, creating an ongoing cat and mouse game. Google's infrastructure and expertise enabled more: Gmail, Google Maps, YouTube, Android, Chrome, and cloud. The technologies developed to solve search became platforms for an empire. The paper has been cited over 25,000 times, making it one of the most cited computer science papers. It influenced web mining research, social network analysis, citation analysis, and recommendation systems. The eigenvector-based approach to network analysis found applications far beyond web search. In 1999, Brin and Page offered to sell Google to Excite for $750,000, wanting to return to their PhD studies. Excite's CEO rejected the offer as too expensive. Today, that decision is considered one of the worst in business history. The Google paper offers timeless lessons. Use the data you have, think recursively, combine signals, and scale matters. Research papers can become world-changing businesses. Looking back, some aspects seem dated. The paper describes a crawl of 24 million pages. Today's web has hundreds of billions. PageRank alone became insufficient. Modern search uses thousands of signals, and advertising skepticism gave way to advertising reality. But the core insight, using link structure as a quality signal, remains fundamental. Modern search is far more sophisticated, using machine learning models, personalization, knowledge graphs, and real-time indexing. But PageRank's descendants still run. Link authority remains a core ranking signal, evolved but recognizable. The anatomy of a large-scale hypertextual web search engine is more than a technical paper. It's the founding document of the modern web. Brin and Page showed that the web structure contained information about quality that nobody else was using. They built a system to exploit this insight at massive scale. The result was a search engine so good it became synonymous with finding information online, and a company that grew from a Stanford garage to one of the most valuable in human history. When you Google something today, you're using technology that traces directly to two graduate students and their insight about links, votes, and authority.